Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. My name is Fadjar Goembira, and I'm going to present the results of my research entitled Analysis of Particulate Matter 2.5, Carbon Monoxide, Carbon Dioxide, CO per CO2 ratio, and rate of fuel consumption from the use of biomass stove fueled by corn cob and rice husk. My research team uh, also include Robi Wahyudi Putra and Taufik Insan, and we are from Department of Environmental Engineering, Faculty of Engineering, Universitas Andalas. This is the outline of my presentation, and I would like to start first with the background. And from the data obtained from the Bureau of Statistics of Indonesia, in 2014 there are around 5.7 million tons of corn cobs and 17.0 million tons of rice husk generated in Indonesia. And we also know that at the moment we rely mostly on the fossil fuels, where we actually remove the carbon from the underground into the atmosphere, that further cause the global warming issue. And there's a new concept called the use of biomass for fuel, where we burn biomass and then the burning process will emit or release carbon into the atmosphere. However, the carbon will be absorbed back by the plantation, which is part of biomass that we use. Therefore, this process is considered as carbon neutral. However, when we use the biomass, there is also another issue, which is the indoor air pollution. As we see from this picture in the slide, that the smoke from the use of biomass can be uh, so much generated, it can harm the people nearby. So in this research we use this kind of biomass stove, and we use corn cobs and rice husks as the fuel, biomass the biomass fuel. The objective of this research was to analyze the potential indoor air pollution related to PM 2.5, which is particulate matter with the size lesser than 2.5 micron. And then we also measure carbon monoxide, and to know the efficiency, the combustion efficiency, we also measure carbon dioxide. And then we also try to measure the fuel consumption rate, the amount of fuel used uh, in the research. And to know about the process, we use what is called water boiling test. And this is the research setting. We use a pot filled in water, and then the water is heated up by the biomass that we put into the biomass stove. And during the process, we measure the amount of PM 2.5 by using this low volume airless air sampler, and we also measure the concentration of carbon monoxide and carbon dioxide by use this analyzer. And the water boiling test required us to do the cold start, which means that the boiling process started when the stove was still cold. And then another phase is the hot start, which is the time when we use the stove starting when it's still hot. And then the simmering process is the time when the water is already boiling, and we keep that situation for a certain amount of time. Next is results and discussion. So in this graph we can see that the PM 2.5 concentration in all phases for the two biomasses that we use in this research all were above the maximum value based on Minister of Health regulation. It means that uh, when we use the biomass in the cooking stove, there will be a lot of smoke generated, and this value is not really uh, good for our health, particularly when we use in closed ventilation system in our house. And we can see also from this graph that the corn cobs PM2.5 concentration was higher than that of rice husk. This can be due to uh, the shape of the biomass. Rice husk already in grain state, which can be burned more efficiently than the corn cobs. In the next slide, we can see the comparison of carbon monoxide concentration. We can see here that all of them were also above the maximum value based on Minister of Regulation, Health Regulation. So in this regulation, the value is supposed to be maximum 9 ppm part per million for 8 hour of measurement. And we can see from this graph that all of them already above. And this the value is almost the same for the corn cobs and rice husk. And when we compare the CO2, we can get the ratio. The ratio for high efficiency combustion of fuel is 0.02. But in our research, we found all of the value were 3 times or more from 0.02, which shows that the combustion efficiency is quite low if we use corn cobs and rice husk without any modification. And then when we compare with our previous work, in our previous work we evaluated the use of firewood, coconut shell and oil palm kernel cells, and in this graph we can see that the corn cobs and rice husk we need more fuel to achieve the same state or the same phase in the water boiling test as compared to the previous biomasses. So it means that the energy density of the corn cobs and rice husk were lesser than that of firewood, coconut shell and oil palm kernel cells. And in conclusion, we can present here that PM2.5 and CO concentration was still above maximum allowable value. So regarding to the PM2.5, there will be a lot of smoke generated during the process. CO is we cannot see CO, we cannot smell CO, so it is very harmful if we use the biomass by using the biomass stove and in a closed ventilation system. And then higher CO to CO2 ratio than 0.02 shows that the imperfect compaction when we use corn cob and rice husk. So have to do something with the biomass to reduce the CO to CO2 ratio. And when we compare with the previous work, this biomasses used in this research, we need more of them to reach or to obtain the same state of the water boiling test. So based on that conclusion, we plan the future work to improve fuel density, for example by converting biomass into biopellets. That's all my presentation. Thank you very much for your kind attention, and thank you very much for Faculty of Engineering who supported me for the publication of this work.